Good afternoon, ladies and gentlemen. I've had two honors. Today we're going to start doing our test preview for what I think will be on Wednesday. And to show you what is going to be covered in this preview and subsequently on the test itself is this kind of table of contents. And really, over the past few weeks, we've done all these things. Does that look like it's a lot?
No, absolutely not.
Not really? So yes and no. But we're going to go over all these things, and when we go over all these things, the idea is you're going to have we're going to cover 80, 90%, pretty almost exactly of what's on the test. So we will see that, maybe even more. But let's go ahead over these things one by one. We have this section here. Here's a function, and we're going to choose true or false for each statement about the function. Now these problems here, based on what we've done in class, you should be able to do these without a calculator. But when you have your test on Wednesday, are you going to even use your calculator over something like this? Most of you, yeah, maybe or maybe not. Just depends on how certain you are of what's going on. Okay, what I do in looking at this thing is I kind of put down like a standard form of this thing, standard vertex form, which is A times x minus h, quantity x minus h squared plus k. Okay, so the first statement here, the axis symmetry is x equals -3. True or false? False, right? What is the actual axis symmetry here? Axis symmetry, actual axis symmetry is x equals 3, not x equals -3. Does everybody understand that? Anybody need to go over this anymore? No? Next, the minimum value is 4. True or false? It is true. Okay, when you graph this thing, you have h comma k, so 3 comma 4. So the thing's going to come right like this. Does that look right? Minimum value is 4. Is the maximum value -3?
False.
False. And is it possible for the same equation, a quadratic equation, to have both a minimum and a maximum? No. So at least one of them has to be false. Next to the statement here, the function is increasing on 3 to infinity. Is that true? True. Then the function is decreasing on -infinity to -4. Decreasing from -infinity to 3, but not to 4, because we're turning the corner there. All right. Any questions on this section? Let's go on then. Identify the domain and range of the function, gives the function there. What is our domain of this guy here? Okay, Jay is trying to tell me through a yawn. He was yawning. This is what he was saying when he was yawning, I think. If that would be our interval notation, and inequality notation, we would do inequality notation like this. Okay. And what is the range of this function here? So negative infinity to -5. Bracket, right? Okay, as a rule of thumb, if A, in this case, is less than 0, range is equal to negative infinity all the way up to K. Okay? So that's where, this case, K is equal to -5. So that's going to be our range. If A is greater than 0, range is equal to K comma infinity. All right? Does that make sense a little bit? I hope. Yes. What's that thing doing? I don't know what my pen is doing here. Here we go. Okay, next, completing the square. Write the quadratic function vertex form by completing the square. Does anybody remember about completing the square in this class? A little bit. Yeah, so just try to work that one out. Well, go over it here a little bit. remember pretty well about how to do this one? Jay's shaking no. Anybody remember pretty well? Gabby, you remember how to do it? Gabby says she does. Ben, you remember how to do it? Somewhat, all right. So, what we're going to do here to complete the square, we're going to put f of x, put an open parentheses here, and put x squared minus 8x plus, I'm going to leave these little dots here representing a blank. And then on the outside, I'm going to put a subtraction here and put some dots here, and then put plus 3 out here. Okay? So we need to figure out what goes in that first blank to make a complete square along with that x squared plus 8x. How do we find that out? Yeah, you take half of it. So I'm going to do a little side problem over here on the left. So I put 8 over 2, which equals, or negative 8, excuse me, equals negative 4. And so when I do that, I'm going to put this little asterisk right above this negative 4. Okay? And we'll see what happens then. What goes next?
And you square it?
So negative 4 squared is equal to 16. So 16 is what goes here. And what goes out here?
4, negative 4.
Okay, minus 16. Okay, we got to make sure that whatever we add here, we subtract the same thing on the outside. And now we're ready to write our answer. We put f of x equals, and here's where that asterisk comes in play here. So what is going to go here? X minus 4 squared, and then we take this negative 16 plus 3, which is minus 13. And then what's the last thing you're going to do after you work all this out? You're going to check, Ben says calculator. Check using the calculator. Make sure you get the same thing. How's everybody on that? Okay? Questions on this one? Okay. What I want to do is I want to give you another problem that's very similar to it. Work that one out. Another completing the square problem. Hand out some papers whilst you do that. Okay. What I did with this one is I've worked this out in my head. I did second period. Was anybody else able to work this out in your head? A little bit? You did it in your head a little bit. Okay, to do in your head, you can do this pretty easily. If you take this 10 divided by 2, what's that? 5, right? So that's a number you have to remember, that's asterisk. And then what's 5 squared? 25. And so inside you add 25, so what do you have to do when you add 25 to complete the square? Subtract 25. So when you think of it that way, what you have is you have f of x is equal to x plus 5 squared, and then you have minus 25 minus 9, which is minus 34. Is that what you got for your answer on that? Questions on that? Okay, so it's supposed to be f of x, not very legible. Okay, so you have a couple problems like that on your test, okay? Should be ready for that. Questions on that? I don't think on your test you're going to have anything like 2x squared or a negative sign out front, so that's obviously is going to make that test easier. So that's fine. Okay, next. Do the following functions have either a maximum or minimum value of 5? So I want you to work on these right here, and we'll talk about those in a couple minutes. What's going to be your strategy on these problems here? Okay, Jaden says calculator. If I am doing a test like you will be on Wednesday, and I want to, 1, be sure I get the problem right, 2, maybe save some time, I might go to the calculator first thing. But what other way, because that's right, that's probably what I would do or recommend doing. If you didn't have a calculator, what would you do for this? Yeah, if I didn't have a calculator, what I would do is I'd go back here and do them like this, okay? Complete the square to get that. That's what I would do. And then you'd have your h and k, and then if k was equal to 5, then you know you have it right. Okay, so what did you get for these? What about the first one? Yes? So yes, right? Yes. This second one, is that a yes or a no? It is a no. This third one is a yes. It's just, anybody need me to graph in the calculator, see what it looks like? Abigail, yeah. You do? Okay, x squared plus 8x plus 21, so we'll do that quickly. Okay, x squared plus 8x plus 21. Now I'm going to go to standard window by going zoom 6. And so here's a minimum value of 1, 2, 3, 4, 5. Minimum value is 5. Yes. Okay, next one is this x squared minus 6x plus 2. And now graphing the blue one, say we get, this is a minimum, but that's a minimum of like -7. So that's not right, okay? And then the last one we have is -x² plus 4x plus 1. -x² plus 4x plus 1. And so here we have a maximum of 5. Right? So that one is yes, the red one. This lavender one is yes, but this time is a maximum. And then this blue one has neither the minimum is not 5. Okay. Next, we have a rocket that is launched upward at a speed of 192 feet per second from a platform 6 feet above ground. Find 1, the rocket's maximum height in feet, and 2, the number of seconds required for the rocket to reach that maximum height or elevation. How would you do this problem?
I feel like you maybe need to draw like a little thing out, that way you remember your 6 feet. And then,
Yeah, so Bryce is suggesting maybe making a drawing of that, right? So you make a drawing. What else? Is there something you have to know or remember to build? So Ben is shaking his head yes.
the formula.
Okay, we have to know what the formula is or remember the formula. And what is that formula going to be? It's been a while. Okay, I'm going to put h of t means height as a function of time is equal to okay, t squared is part of this, but what times t squared? You don't remember. How about -16? Plus, what's the next thing here? I'll write it down what it is. It's called v sub 0 t. And the last thing is plus h sub 0. Okay, does that make sense? Does anybody have some kind of faint remembrance of that? It's probably on some of the papers I handed back to you somewhere at some point, if not last week, at least the week before that. Yeah, I think it was the week before that we actually worked on that. Okay. What next?
Insert value.
What'd you say?
Insert the value.
Insert the values. Okay, let's insert the values. H of t is equal to -16 t squared, right? We can't change that at all. Then what?
Plus 192 plus 6.
So there's our function. Okay, so we just replaced v sub 0 and h sub 0 with 192 and 6 respectively. Okay? And then we're asked to find the rocket's maximum height in feet, first of all, and then secondly, the number of seconds required for the rocket to reach that maximum elevation. What do you do with that?
Leave it apart.
Okay, Ben says complete the square. You can actually complete the square, and I might do that as a little side problem. But you know, when you complete the square, well, let's go, since Ben mentioned it, let's do it. Because when we complete the square, we are actually going to have the answer to the question, right? So we're going to put, I'm going to put negative 16 out here, and here I'm going to put t squared. And then what times negative 16 equals 192? You can take 192 divided by 16, and that's what it is here.
12.
12, okay. So we'll say, and that's going to be minus, and we need plus, so it's going to be minus 12t, right? Plus something here, and then something outside here, and then plus 6. Okay, what do we do to find what number goes here? Negative 12 divided by 2 is negative 6. Asterisk that negative 6, right? And then what do we do with that negative 6? Negative 6 squared is 36. So we're going to put 36 here, and what goes out here?
Minus 36.
Minus 36. Well, here,
No,
what we're going to have to do is we have to counteract that. So we're going to put plus
Oh, yeah.
16 times 36.
That's right.
So now we can write this as negative, excuse me, negative 16, and we have t minus 6 squared, and that's where our asterisk comes from, minus 6. And then what's this? What's 16 times 36 plus 6?
82, or 582.
582, right? So now we can answer the question, which is how many seconds? Or what's the maximum height?
580.
582 feet. And how many seconds does that take?
3.3.
That's 6 seconds. Okay? And then, so that's really without, I mean, you use a calculator for some of these bigger numbers, but really,
How's it 6 seconds if it's launched at 192 feet per second? So wouldn't you take 585 and divide it by 192?
582.
Because if it was 6 seconds, it'd be closer to 100 feet per second.
yeah, that's for height, but we got gravity working against it, see? And gravity takes it down pretty fast. And I know that, so you're saying that it defies your intuition is what you're telling me. Yeah, and that's right. To think that way, that's a good way to do it. One way that most people do it is really just to graph this in the calculator like this. And I'll show that to you here. So if we take negative 16 x squared plus 192x plus 6, and we graph, we'll see this. We won't see very well. We need to change our window. So I'm going to go 0 to 12 by ones, and I'm going to go up to y minimum. I'm going to leave that alone. I'm going to go up to 700 feet maximum here by 100s. And then we graph, we see this right here. Okay? How do you find the maximum after you graph it? Yeah, you can find the vertex. Now some people go to the table. I will tell you that if you go to the table, one thing you got to watch out for is Well, here you have this, I have it set up from last class, table set. Standard table would be like table start at 0 by 1s. That's like your default setting. So if you go here, you're going to see a maximum height of 582 feet at 6 seconds. But sometimes that's not going to be 100% correct unless you have perfect symmetry about the line, y equals 6. In this case, it is correct. We did complete square. Second trace 5, or second trace 4 for maximum. We have this question mark left bound, and you arrow over to the left of the vertex. Make sure you're to the left. Press enter. It has a question mark. And then you arrow to the right of the vertex and press enter twice more. And you get your answer, right? Now, remember we found out it was 6 seconds. Where did this 0.000014 come from? Where did that come from? Any ideas? The calculator has little calculator idiosyncrasies to it that's like a rounding error, because the thing estimates to give the answer. In this case, it is 1, 2, 3, 4, 5, 6. So this is 14 10 millionths off, essentially, in the rounding error. So when you see these numbers very close to an actual integer, but off by millionths or billionths or trillionths, that means that it's really going to be that exact number, whatever it is. So the calculator in this case confirmed what we got by completing the square. Now I would expect maybe all my students to just go to the calculator first of all and work that out instead of completing the square at it. But completing the square gives us an exact answer, right? And it's really not too bad, but you have some complexity with having to figure out what you multiply by and so forth. So there is some complexity to it. So just be ready for it. Okay, the last thing I want us to look at today is this one right here. Find an approximate quadratic function model for the graph data by estimating the coordinates of the vertex and using one other point. What would you estimate as a vertex here for this?
3, -2.
Yeah, to me, if you have symmetry like this, there's no, I mean, I don't have any other reasonable alternative than to pick what Jade did, right? 3, -2. And then one other point. What is your other point you'd like to use on this?
7,
7, 1? Now you could, now as it turns out, I think what I did in the test review video, I think I used this -1, 1. But 7, 1 is a good one. Another one you could use that might make sense is this one over here. In fact, in my other class today, I think they used -2, 3. But would either one still be a sufficiently correct answer according to the instructions?
Mm-hmm.
Yeah. So I'm going to go with Jaden's suggestion here. And so we're going to have f of x equals a times x, what is that? Minus
7.
3
Oh yeah, 3.
squared, and then minus 2. And now, if we plug in this point, what would we do for that? We would have 1 equals a times, we would have 7 minus 3 squared minus 2. So next, if you added 2, you would get 3 equals 7 minus 2 squared, 16A, right? So A is going to be equal to 3/16. So we would have f of x is equal to 3/16. We'd have x minus 3, quantity squared, minus 2.
I'm confused, because isn't the point the vertex, did we use -2, 3 for the vertex?
No, 2, -3. 3, -2.
3, -2.
Oh, okay. Okay, I got confused because you had the other one circled, so I got confused.
Yeah, this one right here is the extra point that another class used today.
Oh,
Okay, this is the one that Jaden did. I think when I made the test review video, I think I used this one over here. But the point is the same. It's better to use one that's not right next to it here. It's better to use one that's a little farther out. And so now we graph this in the calculator. We get 3/16. Oops. X minus 3 squared minus 2, and then we graph. I'm going to go zoom 6. So we have our exact points here. We have this 7, 1. We have this negative 1, 1. And remember that we had that negative 2, 3? Not quite exactly, so we're not going to hit that point. We're not going to hit negative 2, 3 exactly. But you can see that's pretty close though, right? So really, that's as far into this as I want it. Basically, you're going to use your justification, and you're going to also be asked to sketch a graph of that. Okay? So is that going to be very hard? No? Okay, well good. Well, we will then, ladies and gentlemen, just leave it there for today and resume on Tuesday. Thank you.